Hi, everyone, and welcome to another edition of The Boring Show. My name is Fitz. I'll be your host for today, and it's just me. We're going to be diving into the source code again. And so my goal for today is to really think about what is happening when we call that runApp function right at the top. So every Flutter app starts with main and then runApp, and then it goes into it. And for some of you, I'm sure this is going to be content you already know, but for many, maybe not. And so we're going to talk about what happens when you're actually calling the runApp. And part of the reason here is because often you look at this, and so here I've got my counter app, right? And we have my app, and it has the Flutter demo, the theme, the material app, my homepage, and all of that stuff. And runApp is given my app. So naturally, you look at this and you say, yeah, my app is the root of my app. I'm running this app. It's what it's going to be. So, and we all know this creates a widget tree, so at the root of the widget tree is this my app, right? So it's not actually that though. So if we click into runApp and we look at this and we see that, okay, runApp, it inflates the given widget, attaches it to the screen. Okay, so there's two things that we might want to investigate here. What does inflating a widget mean? What does attaching it to the screen mean? Because I thought widgets were attached to a tree, right? And so those are two questions we'll hold on to ourselves for later that we might try to answer. And in the meantime, we're going to see what runApp is actually doing. So we've got this runApp. It's given some sort of widget. And okay, so we ensure that our widget's Flutter binding is initialized. That sounds reasonable. Making sure, what does this do? We create and initialize if necessary, and you only need to include it if you need the binding to be initialized before calling runApp. So this would be in the case of you need some plugins or packages that are instantiated before calling runApp. Like shared preferences is a good example, at least it has been in the past, where you need to ensure initializes beforehand. Okay, so that's the first thing we do. And then we schedule attach root widget. Okay, so what is that doing? Well, we look into that. And we schedule a timer for calling that. Okay. So by doing the timer.run, we are allowing something to happen asynchronously. So allowing the framework to move on to whatever else it needs to do, allowing Dart to move on to whatever else it needs to do, but also making sure that at some point in the almost immediate future, we schedule attaching this root widget. Okay, so if you recall, that root widget was our app that we passed in. So attach root widget, we take that widget and we attach it. Okay, so that pops us down to here. And let's see, takes a widget and attaches it to the render view element. Okay, so now we're getting into some of these notions of the multiple trees, right? Because there's not just the widget tree, there's also the render object tree and the element tree and a few other trees. And so we're combining these ideas into one render view element. Okay, we'll come back to that. So given this root widget, we are trying to attach it. And when we get down into it, we've got this render view element being set to a new render object to widget adapter. Interesting. And the child of that is our root widget. So that thing that we thought was that root widget, remember that root widget was the app, the widget that we passed to runApp, and it's not actually the root. So it's the child of something else. It's this child of a render object to widget adapter. So we'll look at that in a second. And when we create that, we then attach it to the render tree. And that kind of makes sense. This is a render object something or other, and so it might make sense that it's part of the render tree. But let's look at this object. Let's look at this render object to widget adapter. What do we say this is? This is a bridge from a render object to an element tree. Ooh, so you know how we say the multiple trees. There's the render tree, and there's the element tree, and there's the widget tree. Okay. It makes sense then that we have some way to connect these things and make sure that they are somehow tied together. So a bridge between these two trees. Great. So the given container is the render object that the tree should be inserted into. Okay, and it must be a render object that implements the render object with children protocol. Okay. So what do we do here? We have a child widget that would be that root widget that we have. We have the render object that is the parent of the element created by this. So I would guess that this means, and this is a guess, that this render object is the overall the thing that is going to contain the entirety of the app. That is, we are starting with the root of the widget after all, right? So we can get into it. Let's see, we've got an empty update render object. And we've got the attached to render tree. So this is mostly collecting things so far that allow us access to other parts of other trees. So like the widgets and the render objects. So the other thing that if we go backwards slightly, keep going backwards. Yeah, this attach root widget was this attach to render tree. So here, if our element is null, we will we need to create one, and that's going to be just our default or our overridden render object to widget element. So the elements, remember, are the instantiations of our widget. So if the widget is the just configuration for something in the tree, the element is going to be the actual manifestation of it in the framework, in the runtime. So we'll have this render object to widget element. And okay, so there's two different branches here. One is going to be run on the first time we go through creating this render object bridge between things. Render object to widget adapter. Because the first time we run it, so the constructor here takes a child container and a short description. Okay, now the container by default, when we first create this, is going to be this render view thing, which is our root thing, root pipeline. Ooh, that's something else to check for. That's probably going to be our overall place to draw things, our top level render object. And we go into that. And so the first time we run this, the element is null. There's no element that we've created yet. And so the very first time we create this, we do this runApp, we're going to have to create that manifestation of this new root widget, because the root widget that we thought we were creating, the my app, is not actually the root widget. It is the child of this render object to widget element. And that then also needs its own element. So we create that. We ensure it gets created correctly, and then we assign this owner thing. Okay, so when we attach to render tree, we are passed an owner, and then what else is on this list? And possibly an element. Okay, so what was passed into this initial call to attach root widget? When I attach, we have the build owner and we're guaranteeing that this is not null. Okay, great. And the render view element as that object to widget element. And what is this build owner then? Who is our build owner? The build owner is in charge of executing the build pipeline for the widget tree rooted at this binding. Okay, so the build owner is responsible for building. That makes mostly sense. We'll maybe come back to this with this build owner class. Manager class for the widgets framework. Class tracks which widgets need rebuilding and handles other tasks that apply to the widget tree. Okay, so I'm going to guess that this is going to come back into play when we have widgets or elements or render objects that are marked as dirty. That's going to mark us for when we need to rebuild things. So that's probably going to come back in the future. In the meantime, so we're saying that we have this build owner. So I'm curious, actually, where, if we're guaranteeing that this is not null, where does this actually get created for the first time? Okay. So that we got. So we first stop, we did our ensure initialized, which created our widgets flutter binding, which has nothing in it other than see, it has some mix-ins and the binding base. Which one of you is going to give me that builder, that build owner? Might not be there. It could be. There's a lot going on there. We'll come back. There's a lot of things we're going to come back to. So we have attach root widget. The build owner is there. Let's see. Let's find all references to this build owner. Where do you get created? So the first time it's going to happen in the widgets binding mix-in, and I guess that makes sense, right? Because the build owner, if we remember the docs for this, it manages the build process for widgets. Okay, so that makes sense then. That makes sense to me that this is part of the widgets binding if the build owner is responsible for the widgets. Okay, so That's going to get created as part of creating that initial instance of the widgets binding. So if we go backwards slightly to remind ourselves that the very beginning, we ensure initialize of this widgets flutter binding thing. And when we create that, we're extending and mixing in all of these different things, and then getting the instance that we're actually going to use for that, if it's been created. Cool. Okay, so it's that widgets binding that creates the build owner. What else did that do? Let's go back to that. Where was that? Build owner, find references to get where we set it here. This is part of the init initialized init instance, which is called all over the place. First calls init instances to have, so that's that binding base. That's that first thing that we extended. So this was not from the mixin, but this was from the base class that widgets flutter binding inherits from. So that constructor calls all the init instances for to have all those bindings startup things. And so part of that is going to be the build owner. Great. And a window. Ooh, that's something else, something new. So we have a build owner and we have a window. We have system channels. Okay, so here you go. This is where when you sometimes have some of those plugins that require this widgets binding initialized to happen before runApp, this is probably why there's these system channels, right? And okay, what do we do with this build owner? Handle build scheduled. Ensure visual update. So okay, it was just set to that function. So on build scheduled. Yeah, okay. So we're saying once we have this build owner instance, then its build scheduled function is going to be this handle build schedule. Okay, that kind of makes sense to me. And what I want to do next, so we've found our build owner. We'll back out again. When we have our attached root widget, what do we've got here? So we found our build owner. Great. Our render view element as this particular type. What is our render view element then? That's the other part of making sure that we have our render object widget binding bridge, whatever it was called, properly initialized. Final references. This render view element is created in the line before we came from. So I was looking at this attached to render tree, looking at this render view element as this type that is actually set here, that render object to widget adapter. Okay, so that we are attaching itself. So this render object to widget adapter extends render object widget. Okay, so we just have like a top level render object. But apparently we can cast it as a render object to widget element, which extends a root render object widget, which extends a root object element, which extends an element. Okay. Render object to widget element. What are you? You are can only be used as the root of an element tree. Its parent must be null. It cannot be mounted onto another element. So this really is the root of our tree, this render object to widget element. Ooh, okay. Now, what all is this thing doing? So we can get the widget that we are attached to, or associated with, rather. We can forget children, we can visit children. Okay, so this is part of that. So reading the framework is rife with going through assert statements that all make sure that some of these requirements are actually adhered to. So we have its parent must be null. It's an extra apostrophe. Its parent must be null. So here, if you were to try to mount this render object to widget element to a non-null parent, you would get a crash. Everything would die because we need our parent to be null. This thing must only be the root element and have no parent. So once that's true, then we can mark for rebuild if we were doing a mount. What else do? You we can rebuild with an update after we change out the widget. If we were assigned a new widget. Performing a rebuild, we say if so if the new widget actually has a value, then we want to use that new widget as the updated widget. That makes sense. And then call our parents the superclasses rebuild. So that'd be that root render object element. And rebuild, meanwhile, is going to update child. What do you do? Okay, if it's null, we just there's nothing to update. If our child is not null, then we do some checks for need to gently guide the invalid element out of the tree. Gently guide it out of the tree. Wonder what that means. To do so, we ensure that the has same superclass condition returns false, which prevents us from trying to update the existing element incorrectly. So, old element class, new widget class. We want them to be the same. And there's all kinds of updates that happen here. Ooh, this is a long function. Wow. Okay. We have child slots and old and new widgets. Ultimately, we're returning the new child, probably the inflated widget here. So that was one of our questions, actually. So okay, let's guide this discussion a little bit. Because one of our questions was to answer. So we go back into our main where we went into runApp, and we saw that runApp says it inflates the given widget. Okay, so eventually we come down here and we land on an inflate widget. Okay, so inflating a widget. What does that mean? So we have some key management here, making sure that we are managing the right widget. Otherwise, so we've got this new widget. We create the element for it. So an element is the instantiation of a widget. A widget just being the configuration, more or less. So we create an element. So we have that new element, and we mount it into whatever the root tree. So remember that this inflate widget we found from the that root render object element class, and so we're saying that this new child, that first child that we passed into runApp, is going to be, so we create the element version of this, we mount it on as the child of this root render object. Meanwhile, the new slot that we have was this new slot. What is the new slot? Let's find it. Where is it? Where are you? Where are you set? From update child. References. There's a lot of them. Can I just go backwards? No, I can't just go backwards. Okay. So where is that? At least one of them came from here. The root child slot was from our rebuild. A root child slot is just an object. We're still in the root. Yeah, we are still in the root one. And we got there from the rebuild, which says, so the root child slot, I guess, makes sense that it's just an object, right? Because there's no pre-existing place that we want to put it in among all of the siblings. It's just straight up just the one. I guess that makes sense. Is there documentation on saying what this slot is? The new slot argument specifies the new value for this element's slot. Okay, that's not terribly useful. What does the slot mean? The slot is the information set by the parent to define where this child fits in the parent's child list. Okay, so it is which child specifically it is. And so if it's see render object element for more information on slots. Detaching, handling errors, which child during layout. I want to know if I pass just an empty object just an object as the slot. What does that really mean? Each child element corresponds to a render object, which should be attached to this element's render object as a child. Okay, I think I know that. A slot token. This is an identifier whose meaning is private to this render object element node. When the descendant that produces this is ready to attach it to this node's object, it passes that slot token back to this node, and that allows this node to cheaply identify where to put the child render object relative to others in the parent render object. So it seems to me like it's kind of a an index into which one of the node's child that widget is. And so again, I come back to if it's our first widget, like the root one, then there's only going to be one. And this root render object thing only has the single child. And so this root child slot is probably never going to change. Let's go back to the find references on this, where we see that root child slot is set to that empty object, just an object, nothing else. It gets used there, and never changes. So yeah, that root child slot is just always the same, always in the same place. And then it's up, at least where I've found so far. So, okay, once we update the child, this is where we found that inflate widget. So when we're inflating a widget, what we really mean is this create element, where we are having that widget become a real thing. So remember, the create element is the instantiation of a widget. It's the real thing. Real being relative because we're talking about code. But if it's we're making it an actual thing, and then we mount it into here. So okay, now right, let's back up a little bit. Where we started, we had inflate the given widget. We got there eventually. We made it to a point where we found that inflating the widget is creating the element that represents this widget and attaches it to the screen is the other question that we haven't answered yet. So I want to look at this and see if we can answer that question. So we have this render object to widget element, which extends a root render object element. And those are our assign owner. So that build owner is going to be assigned there. We mount it, can't be mounted anywhere. Root element should never have parents. Fine. That makes sense. Root element should never have parents. And that's that. What else does the render object element do? Well, we have our render objects. Find ancestor for a root is going to be nothing. Mount was overridden by the root one. I want to know what it means to attach to the screen. Let's go and check what this warm-up frame does. Schedule warm-up frame. Schedule a frame to run as soon as possible. Okay, that makes sense for the very first runApp call, because we presumably want this to run it as soon as the widget is inflated and ready to go. So let's see, we're going to start. We have a new task. We're warming up the frame. And handle begin frame. And so we begin the frame, we draw the frame, and then we finish. Okay, so let's look at begin and draw. Those are going to be our next places to go. We verify that and we have a debug banner. We verify that we're idle so that we can run a frame. That would be my guess. I'm not sure yet, though. Transient frame callbacks. And so timeline task, we're going to animate it causes these events to show up in the observatory timeline. So this is part of what's going to help. So timeline task. Okay, this is going to help us debug in the future if we want to see where some of these render events are happening. Okay, and then got transient callbacks, which don't know what they are yet. Invoke frame callback. So for each of those callbacks, we invoke them. But what are the transient callbacks? What are you, transient callbacks? What are you? Find all transient callbacks. Because that's just a map of some identifier to a frame callback entry. New frame callback entry. So what is this? Schedule frame callback. We get our new frame callback entry of callback. Okay, where does this come from? Nowhere. Everywhere. It's just in documentation. Right? All of these are documentation. Oops. See scheduler binding handle begin frame. That's where I came from, isn't it? It is where I came from. Because we were here, and I was trying to determine down here where these transient callbacks come from. And this schedule frame callback function. I have no idea where you're called from. Where are you called from? Because it only shows up in documentation. Interesting. So this is where those ticks come in. Schedule tick, because the tickers are a large part of how these frames know to happen. Okay, let's back up a second and see if we can figure out where that happens. I'm gonna go backwards through my poking around. So that, remember, the handle begin frame was one of our there was the handle begin frame and then handle drawing the frame. So this is all part of scheduling the warm-up frame. Scheduling the warm-up frame is part of what? Just top-level framework code? No, it was part of the widgets binding, wasn't it? runApp. We do our Flutter widgets binding, and then we schedule a warm-up frame. Yeah, so this is part of our bindings. And so does this binding have then a ticker of some kind? It ought to, shouldn't it? Let's go about this a different direction. Let's look at runApp. Let's look at our Flutter widgets binding. We've got our binding-based scheduler binding. It might be under there. Let's go look at the scheduler binding since we're talking about scheduling things, which is on that add timings callback. Ooh, that's starting to maybe get somewhere. Add timings callback. Callback. What were we adding? Timings dot for each post event. Ooh, okay, now what is the timing? So many levels of indirection. Oh, so we're actually adding this function where for each profile frame post events. Ooh, what is that doing? We are all over the place with this, you know? Post event. Okay, so it just posts, gives us some debugging information. Okay, that's useful, but doesn't tell us anything about our timers or ticks or attaching to a screen, which is where we started from. We do have this window thing. That variable showed up a while ago as well. Ooh, something about multi-window support. I'm going to talk to Greg Spencer about that. Singleton Flutter window. We have our window, which we get from the UI.window. This is our binding base. What is our UI.window? Singleton Flutter window equals the Singleton Flutter window dot platform dispatcher instance. What is the Singleton Flutter window? Is this window sounds like a screen to me almost. What are they different? Are they different? Window versus a screen? Extends Flutter window. Singleton Flutter window. Okay, so I bet that Singleton Flutter window is related to that multi-window comment. View configuration. Top-level platform window displaying a Flutter layer tree drawn from a scene. Ooh, okay, so this is exactly where we're getting towards that screen idea with this window, where we have those views. And looks like we're getting close to time. Just poking around on the source code. So maybe let's take a moment to recap where we went and where we might need to go next. So the main thing to note here is that runApp, it does take your widget, your root widget, and creates the element that is the manifestation of the widget you are giving it. It then attaches it to a root render object, right? This widget is attached to a render object to widget adapter / render object to widget element. This thing that is going to be able to tie our elements and render objects together so that we can actually draw something. This render view is going to be our initial thing that handles the rendering, the actual drawing of things to the screen. So if we look at that, this is just a render view, which is our render object. Remember, render objects are the things that can draw things eventually as we go through those layers of indirection. And there's our window, our view window showing up. So once we create that first root render object, we get access to this window that we can actually start drawing to eventually. And that's in the very short version, after we've been here for a few minutes together, what that's doing. So we create the couple of different trees and attach and give them the information they need in order to start building the ability to draw to a window or a screen. And then we say, okay, let's schedule a frame to be drawn. So that warm up frame, the initial starting up of your app. So lots and lots of things involved in just that initial run app, beyond just creating a tree. It is doing that, but there's a lot of other things that it's doing. So I'm going to end it there for today's Boring Show episode, and I hope you stayed with me through the whole thing. We jumped around a whole bunch, but next time we'll maybe get back to some actual writing of code. In the meantime, thanks everyone, and we'll see you later.